Tech tip. Today's tech tip is how to ensure body-to-body connections remain associative to geometry. Turning it over to Matt.
Thanks, Dan. And the tech tip for today is going to focus on ensuring body-to-body connections. These could be springs, they could be beams, they could even be joints. How to ensure that they remain associative to relative changes in the position of the geometry. So what we're showing here is a typical body-to-body spring between two bodies in the assembly. I've already got two of them created. When you go and create these, you might be doing them a number of different ways. I'm just going to take one of these here and duplicate it, and then rescope it to a new position or a new face on the respective components of the assembly. And then doing so, you look like you have a typical body-to-body connection. And then maybe you go back to your geometry source. In this case, I'm going to go back to Design Modeler, and I have these two plates positioned with respect to each other. And we may shift the position of those bodies in the assembly a little bit. And when we go back to the mechanical model and do an update from geometry source, we would hope that the springs maintain their correct positions with respect to those two assembly components. So once we do that, what you may find, you may have run into this before, what you may find is that even though the connections appear to remain scoped to the appropriate components or surfaces of each component, the position of the spring itself is not updated. So I'm going to show you a way today to make sure that if you're changing relative positions of components within an assembly, that those components and those springs remain associative to those components. So let's go to a different version of that model. And I'm going to build, the focus here is going to be to reference each of those body-to-body springs to a specific coordinate system. Okay, so I'm going to take and create a coordinate system at each of those hole centers. And at this point, I could duplicate this coordinate system 6 times. Later on, or 5 times. Later on, we're going to use something called the object generator in order to replicate things. But for now, let's go ahead and just duplicate 5 times to get a total of 6 local coordinate systems, and then we're just going to change the scope here for each one of these. A couple more to go here. And then we're just going to ensure once again that we have 6 local coordinate systems defined between each of those plates. I've also set up, you can see name selections in the assembly. This isn't required. It's just I'm going to use it to generate the 2 additional springs once I generate a single of them. That way we won't have to duplicate. It's sort of a shortcut. So we'll show you that. So these 2 name selections, one are for the whole surfaces in the bottom plate. The other one is for the whole surface in the top plate. We're going to go to our connections branch. We're going to do a body-to-body spring. And again, this approach could work for body-to-body beams. It could work for a number of the body-to-body joints that require scoping between 2 positions on relative assembly components. So we'll put in an arbitrary spring constant here. And then we'll go ahead and scope the reference points again, the whole surfaces. But in the definition of each of those references, we're going to use those local coordinate systems. So coordinate system 1, from the top plate, we're going to reset its XYZ components to the origin of that local coordinate system. And then here, we're going to use coordinate system 4, and once again, rescope the XYZ coordinates back to 0, 0, 0. That's the most important step, because now we're essentially referencing this face that belongs to coordinate system 1, and it's always going to be at the 0, 0, 0 origin of that coordinate system. Once the assembly components move, the coordinate system moves with it, and therefore we still maintain that 0, 0, 0 position. Okay. So we could take that connection, right mouse button, and duplicate it, or we'll use the object generator to do that. Okay. So let's go ahead and highlight the longitudinal spring, turn on our object generator, and this is where the two name selections come into place. So the bottom plate to the top plate, and here it's just asking me for a distance between those two plates, and I had set that up to be 3 inches, and I'm just going to put a little tolerance on there, and I'm going to say ignore the original. When I generate that, I do get my 2 additional springs, but the very last step is for us to go back and rescope. Now this is coordinate system 2 at a 0, 0, 0 reference location, connecting to coordinate system 5, also at 0, 0, 0. Do that once again for the third spring. This time it's going to be coordinate system 3, connecting to coordinate system 6. So I have my 3 body-to-body springs, each referencing local coordinate systems at the hole center. When I go back to my CAD source, once again change the relative position of those bodies in the assembly, and I test my mechanical model now by doing an update from geometry source. We can see now this time that those springs realign themselves with the relative positions of the hole centers. So that's today's Mallett Tech Tip video of how to ensure body-to-body springs or beams or joints remain associative to relative positions in the changes of geometry.